Like I said, all information is posted here on this website. In our first presentation is going to be the talk about program in memory. But one more note regarding the book chapters, because we're going to be transitioning from week 1 to week 2, naturally next week. Your homework right now is actually reading those pages, or, like I said, finding information online, which is relevant to what we're going to talk about today, plus the pages posted for the week 2, right? So your responsibility really is, your weekly responsibility is to keep up reading, okay? And feel free to look up those presentations and see what's in them, because everything is posted. I keep no secrets, okay? Everything I can possibly add to this website related to the material that we're going to cover in this course is already here, okay? I can only add some stuff if I find that I would like to add something, but rather than that, everything is available, so you should stay in charge in terms of following what's happening in class. And the better you prepare, the more you can get from me. Now, your job is to get information out of me. Again, ask questions whenever you feel like when we talk about the presentation. Now, there are 2 links for handouts. One is this, which is basically just a long, like a handout format. I would say you can print it if it ever loads, right? You can print it and you can keep notes. In fact, I strongly recommend keeping notes, because there will be so many things happening in this class that you'll be amazed how much you have to sometimes memorize, okay, different pieces. And everything starts kind of simple, but then suddenly gets more complicated and more abstract and a little confusing. So keeping notes is important. Okay. Well, we'll do our best. As you can see, I'm recording this stuff. So this thing here, this whole thing is for you to print if you'd like to print. And keep notes directly on it. The second link is presentation, which basically breaks down individual pieces here into individual, like, small web pages, which I call slides, but they're not PowerPoint slides, they're just plain HTML, but they're generated from the same source, so you don't have to, if you'd like to print things, don't worry about presentation, just print the lecture handout and you'll be good. Okay, CS 123 official name for us is going to be, or is, object-oriented concepts, but in order to get to these concepts in terms of what are good principles of object-oriented programming, we're going to cover the following topics: the CPU, okay, just like our basic knowledge about the CPU, the central processing unit inside your mobile phone or tablet or laptop or desktop computer or mainframe, whatever it is. Modern architecture pretty much kind of relies on the presence of the this processor. Some basic knowledge about the program in memory, and that tells me that we have to talk about computer memory, right? Because if we know what memory looks like and what's important for us as programmers, then we can begin to imagine program in memory. Okay. The data in memory, like, obviously, you know, the stuff that the program has to manipulate, right? If you have a 3D graphics program and you have a cube which rotates, apparently there are coordinates and 3D space and colors and coordinates of light sources and intensity of light and everything else happening there, and mouse clicks and communication with all of that. So all of this is the are examples of data in memory, right? So that's something very important to us, especially our understanding how this data may be located in memory and may be, you know, may look like in memory. Then we're going to look at structures, and structures are like building blocks of classes. In Java, typically you just jump immediately to look at the Java classes, which include data and methods. But in this class, we're going to approach the idea of object from looking at struct, which is C language struct. Very, very simple aggregation of different data pieces. And we're going to, like I said, look at the struct and go to objects in memory and how they can be manipulated at the struct level. And later on, it's going to kind of go more wild with object-oriented concepts, with looking at classes, inheritance, other types of relationship between the classes, and eventually we're going to look at interfaces and how the interfaces to our objects can be implemented. This is something I cannot possibly talk about today in any detail because this is just this is way too abstract to imagine right now. But feel free to research all of these topics whenever you have time, if you feel like doing something like this. All right, so this is the agenda. This is where we're heading. And slowly but surely we'll be covering those things. So hopefully, as we all come in, if you have a cell phone, right, or a laptop, or this desktop in the classroom, right, you may have some idea about a computer program, okay? Maybe you don't know a lot. Maybe you watched some popular science program that was talking about computer science and programming in general. But we'll just say when you say computer is on, right, or cell phone is on, or your tablet device is on, what happens is that your central processing unit, this CPU thing, okay, this is very popular introduction. There's nothing specific, but there's this, microchip basically that has those gazillions of integrated circuitry, which is very, very smart and can do a lot of interesting things. But what it does, it constantly runs a program someplace in memory. What it means that when your device is on, there is computer memory, which is basically space for some data, but that data is not necessarily like numbers or text, right? It's also the programs are also in memory, and your CPU constantly runs a program in memory. So what it means is that when you have some application running, right? An application could be a graphical user interface application with a title bar and a couple of buttons there, right? It may be sitting there and just doing nothing, waiting for you to click or touch screen, touch some gadget on the touch screen, right? But still, the CPU has to constantly kind of check for that. Did it happen? Did it happen? Did it happen? So it constantly executes something, some program in computer memory. That's fine. So the program is made of single instructions that the CPU knows, okay? So the CPU has a set of instructions by design that it can understand. It's pretty low level. I mean, internally, from the standpoint of CPU, it's all like zeros and ones, right? 0, 0, 1, 1, 1, 1 could mean add number, add two numbers, okay? So, or it could mean move thing from one location to another location in memory, okay? Something like that, or duplicate value of some sort. So, so that's what the CPU knows. Now, occasionally, the instructions direct CPU to look at data in memory, okay? So occasionally, besides just doing some computation, it has to retrieve or store data in computer memory. Now, for us, this is very important because all the computer programs that we're planning to write ultimately are going to be doing is basically placing data someplace or retrieving that data from someplace. Okay, there could be a keyboard, could be a touch screen, could be a mouse click, could be a network connection. Okay, but the data goes in and out, and our program does something intelligent with all of the data. So this is kind of interesting information to us, and you can see in every sentence or every bullet here on this slide, there is a memory, memory, memory. So, so memory is basically our focus of our attention at the beginning of our course. So you can formally read about von Neumann architecture machine, which is, you know, decades old, but still has all of its basic elements as part of the modern computer, which is amazing in terms of how long the conceptual stuff, how the hardware is built, lasts all the way through the ages of, you know, mainframes or, you know, computers which were entire floor of the building nowadays to your, you know, pocket device, you know, like an Apple Watch or something, you know, just a little tiny device that can still do a lot of interesting things. So let's take a look at the next slide.